Let me welcome you all, and I want to say that we are very happy to see 49 people in the attendance today. This is this shows quite some interest for the topic of the day. We must assume, so we're happy to see you in such great numbers. We just see the 50th person who connected. And we hope to be able to answer your expectations as much as possible in what we present today. That said, as some of you know, there was during the registration or in the registration form, there was a point where we asked you to share with us what you expect from this webinar. We had a look at your expectations, and I wanted to start off before explaining a little bit the ABCs of eDelivery by making sure that those of you who are attending understand sufficiently well the scope of the webinar to avoid any issues by the end. So this is a webinar dedicated to the exchange of large files with eDelivery using the split and join profile. And some of you were asking questions about features of Domibus, about exchanging normal messages, or even about how can we achieve X, Y, or Z in the once only technical system network or in the eEvidence digital exchange system. So I wanted to clarify that the team that is presenting the webinar to you today is not, let's say, directly involved either in the once only technical system or in the eEvidence digital exchange system or in any of the many other projects that are using eDelivery. We are the core team working on eDelivery, and as such, we present you things from a generic eDelivery perspective, but we will not be able to answer specific questions about the use of eDelivery in a concrete network, such as the two ones I mentioned. I mentioned those two because we saw in the comments we received before the webinar references to these two eDelivery networks or IT systems based on eDelivery. With that said, it doesn't mean that the webinar does not have a lot of value to offer you in terms of learning how this works at the core level in and with eDelivery, but we will not be touching questions about, for instance, the connector that is a specific component used in eCodex and eEvidence, or about a specific configuration that is present in the once only technical system, which involves some third-party systems in addition to eDelivery. With this, maybe we can go to the first slide. Some of you who were with us in previous webinars will of course have seen this before, but for those of you and quite a few of you who are new, I think it's worthwhile reviewing what eDelivery can offer you and what is the larger framework around eDelivery. eDelivery is called a building block. So it is not a turnkey solution that you use directly. It's rather a component that is built into a wider system in order to achieve a certain functionality or to cover a certain functionality. And then on top of this and alongside it, additional building blocks can be used, such as similar ones that are in our offering. And of course, specific dedicated developments and IT systems for the concrete needs of each project. The building blocks that eDelivery is part of are promoting open standards and are in fact built firstly around standards, not around products. So even if today, and as usual, we focus on the product Domibus because that's the one we know and we can operate the best. In fact, this is just always to be seen as an example. The building block at large is promoting the standard, which is implementable by any number of products, and it's actually the case today that some 33 products do so already. So with that said, we can move to the next slide. How do you use eDelivery and essentially any other building block? You can build your own solution if you are so inclined, but that's rather rare these days. But of course, it's an option, at least in theory. You can buy or select a market offered solution, whether for a cost or open source. or you can reuse the sample software we develop as part of the building block itself. In the case of eDelivery, it is Domibus for the AS4 standard that we will be covering today. And of course, we have sample software also for other functions in eDelivery called Domi SMP and Domi SML. So with this, we can move on and see a little bit about the evolution of the adoption of building blocks over time. So the building blocks have been around for quite some time now, and you can see that there is quite a high level of use in different sectors. Some of them represented, I'm sure, by you in the webinar today: e-health, e-justice, e-procurement, social security, agriculture, and so on and so forth. So we can move on and come closely but surely, or slowly but surely, towards the delivery itself. So now we zoom in to what we are doing here in the building block on the delivery, which is about securing the exchange of data over an open network, such as typically the internet. And we do so following four main goals, which you can see on my screen. I will not go into detail around them, but I do want to highlight the fact that what we are promoting is to help you not be forced to use a specific product. So it is, everything we do is vendor and platform agnostic, so you can select any product that is conformant to the specifications, and you will be able to use it interchangeably or compatibly with other products that follow the same specifications. And I think this is a core value that we want to promote with the building blocks, because this way we make sure that we also have a market that can cooperate with us and with you to provide solutions, to provide services, to provide products that are built around the same set of standards. For the rest, maybe we can move on and see a little bit I think this is quite known to most of you already here, but very briefly, what we try to do in eDelivery, both in scope and out of scope, is very similar to what is the case in the paper delivery or in the paper world with the post office. So we are very much like the postal system. And we are in our interface with the IT systems that are specific to a domain, that are specific to a project, is equivalent, let's say, to a post office. So you prepare whatever you want to send via the post office in your own, let's say, business domain, in your own IT system, and then you put it in a sort of an envelope. In our case, it's of course a virtual envelope. You write on the label who it needs to arrive or where it needs to arrive, who is sending it, and a couple of other details. And then the postal system, eDelivery, is going to take care of transporting it. But at the same time, it does not really look inside the envelope. It does not enforce the contents of the envelope. It is merely a transport channel which is agnostic to what is being transported. And of course, it deals with receiving the mail on the one hand and then delivering it on the other hand to its intended recipient. We can move on. And the way this works, of course, happens in a decentralized way, just like the post office, through what we call access points. So what you will be seeing today is the use of 2 access points to exchange large files. But the principle is, of course, the same whether we are talking about small files or large files. We have a sender who prepares a document, a message, a set of documents, a package, whatever you want to call it, provides it to its local access point, where it will be validated, signed, encrypted, sent across the wire to the access point on the other side, where the reverse is happening, in addition to which there is also a signed acknowledgement of receipt, which is produced to guarantee non-repudiation of receipt and sent back to the sender. And then finally, if everything went well, the message will be delivered to its final recipient that you see here in the picture. So we can move on to the same view, where you can actually see the systems connected in what we call a 4-corner model. So typically we refer to the eDelivery access points that are used in the network as corners 2 and 3 that are following an open standard to communicate with one another. And then, of course, the reason why they exist, the raison d'etre for having this eDelivery building block, is to intermediate the communication between the business corners, the business specific corners called 1 and 4, which are typically going to be prepared the data and consume the data that eDelivery simply transports from one end to the other. We can move on. And also to the next slide, please. And here I'm rushing a bit through this because I don't want to use too much time for the introduction. So here we have a slide where you see a selection of projects that are already using or preparing to use eDelivery in their let's say to establish their transport network. You see the two ones I mentioned that many of you here represent, either the once only technical system or the eEvidence digital exchange system. But of course, the contents of the webinar, as I mentioned, will not be specific to these two or to any of the other ones you see on the screen, and there are quite a few. But it will be usable essentially in any of them as long as the right measures that you will learn about today are taken and put into place so that large messages can be exchanged. We can move on. This is our service offering. So in addition to, let's say, the basic patterns that we are embracing in eDelivery, we not only have specifications and software, but we also have services such as to help you do your connectivity testing if you set up an eDelivery access point, or to obtain a certificate to use with eDelivery infrastructure if you prefer to obtain it from us rather than from a CA. We have a service desk which can help you with questions and to install and troubleshoot installations of our software, and a series of other support services, as well as several stakeholder management services such as the one that you are benefiting from today when watching this webinar. And we invite you, of course, to check the details on the slide deck that will be shared after the webinar, where you have some links to register to our newsletter, to register to events, to also be part of our various communities, and in general to stay in touch with us to learn about the evolutions in eDelivery, which I can assure you are quite numerous. We can move on. And yes, before handing over to Cosmin, this is just an updated view of the solutions of the software products that are have currently passed our conformance testing, with several ones that have been added to the mix in the past 6 months or so. So as I hinted at in the beginning, we have now reached around 33 solutions that are conformant. That said, what you will learn about today in terms of the split and join profile enhancement, this is a functionality of eDelivery which is optional. So not all products you see on this slide chose to implement this functionality. They may still do so in the future, and we will collaborate with them if and when needed to make sure that this extension is also tested according to our conformance testing. But certainly some of them have implemented this, and you always have to know that eDelivery is not just a set of common features, but also has a lot of optional parts, and those optional parts, depending on the software vendor, some of them implement them, some of them don't implement them. So you always have to be careful when you talk about a specific feature such as the large file exchange, to check on our website whether the product that you are looking at has implemented this optional feature or not. So with this, I think we can hand over to Cosmin to do the presentation that you are here for.
Thank you, Bogdan. Welcome, everybody. My name is Cosmin Baciu, and today I will show you the how to exchange large files with eDelivery. I will start sharing my screen first. Can you see my screen?
Yes.
Great. So what we will see today, I will start presenting you how to transfer the large files in a classical way, so without split and join. Then we will move on and we will see how to transfer large files using split and join. Afterward, we will see a live demo with two Domibus instances, and we'll transfer a large file between C2 and C3, so two Domibus instances in the cloud. And then we will talk about the split and join limitations that we have in Domibus. Of course, they will have we'll have a section dedicated at the end for Q&A. So first, let's talk about high overview of how to transfer large files in a classical way. So first of all, I would like to mention that the eDelivery AS4 specifications for access points, they have no limitation. So there is no limitation in the specifications regarding the size of messages. So theoretically, there is just we can transfer hundreds of gigabytes. But in practice, the access points implementations, they do have a limitation because of the technologies they use. So for instance, for Domibus has a limitation of 2 gigabytes, and this is coming from the libraries that Domibus uses for for handling the signing and the encryption of the messages. These libraries are mainly ZXF, WSS4J, and Santuario. So to overcome this limitation, we have tried to use streaming when we are using signing and encryption, but we were not successfully in implementing it. So yeah, for the moment, we'll try maybe later on when these libraries will be updated. But what is also worth to mention that when exchanging large files, it is important to ensure that not only the access point can send and receive large files, but also the various infrastructure components that are part of this let's say exchange of large files. When I say this infrastructure component, I refer mainly, for instance, on the sender side, we have a forward proxy, which is handling the internet traffic from the private network to the internet. So this forward proxy must be able to handle large files. But also maybe there are other various components in your infrastructures that are, say, participating in sending large files via the internet. So these components must be able to handle these files. On the receiver side, of course, we have similar infrastructure components. We have the reverse proxy, you have the load balancer, we have the WAF, maybe you have other infrastructure components. And of course, depending on the speed of the network, you have various timeouts of these components that must be configured to avoid the connection between the C2 and C3. I will stop a bit here if in case you have some more questions. By the way, if you have questions during my presentation, please feel free to interrupt me. I would like to have a conversation with you so that I don't have a monologue here. So do you have questions at this stage?
Cosmin, to clarify, I think attendees cannot unmute themselves.
Okay.
This is set up as a webinar, not as a meeting. Therefore, I think questions can be asked on the chat, as Monica announced in the beginning, and we will maybe interrupt you to read them out if you miss them.
Okay, good.
Or they can raise their hand and we will give them the floor. Both options.
Good. Thank you. Okay, so if there are no questions here, I will move on to the next slide. So even in the absence of the limitation in the software products, it is still preferable to use the split the transfer into smaller fragments. And why this is important? Because this will limit the data loss in case there are errors while transferring the message. So imagine you send I don't know 15 gigabytes of file and there is an error, then if you don't split it, then you'll have to restart from scratch. So this is not desired. But also the time that it takes to transfer the message, and then here it's important to mention that I'm coming back to the previous slides. where I was referring to various components which are taking part of in the exchange of files. So this might play also a role. I mean, these components, maybe they cannot handle connections which are open for a large amount of time. Also, when exchanging large files, we need to talk about the memory consumption on both the sending and on the receiving side, because yeah, we have to. There are signings and encryptions that are say taking place. So as I said before, if transmission of a message fails, there is no possibility to resume the transfer. So you have to restart from scratch. This is not a desired way of sending files. And when starting from scratch, of course, the message must be resigned and must be re-encrypted before it must be resent to C3. So the whole process starts again. For instance, when when testing sending large files with Domibus, we have observed that Domibus uses roughly 3-4 times more memory than the exchange message size due to these libraries that Domibus is using, so mainly CXF, WSS4J, and Santuario. These libraries must load the whole message, the whole payloads in memory. There are certain transformations that are taking part in there, and that's why we have this high amount of memory consumption. In terms of CPU consumption, there is no difference between sending a large file and a normal message. So, of course, we need to talk about signing and encryption, but when we talk about split and join, there is no CPU. There is no difference basically comparing with normal user messages. Then let's talk about how to transfer large files using split and join. But first, I would like to mention that split and join is an optional enhancement of the eDelivery AS4 profile, and is based on the Oasis EBXML messaging services version 3.0, so part 2 advanced features. In terms of limitations, there is no limitation in the file type of file formats and the file size. And the optional enhancement for split and join is supported for the moment in Domibus. And to our knowledge, we don't know another access point which supports it. So for the moment, you can use it only in Domibus. So what is split and join? Split and join provides a mechanism for C2 access point to send very large files, even hundreds of gigabytes to a C3. And how this is possible is because C2 splits the message that must be sent. This is called source message into smaller message fragments. We will see later on how this is done, also in the demo. But for the moment, let's see exactly at a high level how this is working. So, and then after C2 splits the source message into fragments, C2 will send each fragment independently to C3 like a normal user message. So from this moment on, there is no difference between split and join and sending, sending a message fragment and a normal user message. And then C3 at the C3 side, it receives each message fragment one by one. And when it receives all the message fragments, it joins them and reconstructs the original source message that was sent by C2. So this is how the large file transfers using split and join is working. If a one message fragment is lost, so I know that's not there is a connection issue, network issue. Only that message fragment is resent in say following the reliability service of the access point. From C1 and C4 point of view, sending large files using split and join is transparent. So the from C1 point of view and C4 point of view, they will not know what is happening between C2 and C3. They will not see that the message has been splitted. There are fragments flowing between C2 and C3. For them, they only see that they have sent a large, C1 sent a large file and C4 will receive that large file, which is good for, let's say, for integration purposes. Now I will explain you in a diagram how this transfer of large files using split and join is working. First of all, please let me know if you see my diagram. I mean, if it's not too small. Otherwise, I'll have to zoom in. Is it okay for you? Can you see it?
Yes, at least it's fine on my screen.
Good. So the whole process starts with the backend C1 here, which will send a large file. In this case, we are using the access point side. So on the Domibus side, we are using the file system plugin. So C1 starts sending the large file. Switch to the laser point on so that you can see it better. So C1 sends the large file to the file system, to the share file system, which is used by the file system plugin. So it just copies the file into a special directory. We will see later on how, just an overview how this is working. So it's after this file is copied on the file system, then the file system plugin will fetch that large file, and then it will construct a message to be submitted to the access points, to the C2 sending access point. After the message is received by the C2 access point, it will save that file into the Domibus file system. So maybe just to mention here that Domibus must be configured to save the payloads on the file system, contrary to the default configuration, which is when it saves the payloads on the database. So it will save that large file on the file system, as you can see it here. And then internally, Domibus, it will create the MIMES envelope soap message, which we have seen that is called a source user message, and splits it into multiple fragments. You can see here fragment 1, fragment 2, and so on. The how Domibus knows how to split this source messages according to the pmod configuration. We will see later on what are the parameters available in there. So then we have these fragments here that are waiting to be received. Domibus will send each fragment as a separate user message to C3. So this fragment, as you know, when sending a user message between C2s and C3s, there is a synchronized receipt for each fragment to ensure the non-repudiation. So the acknowledgement is sent to C2. Then C3 will save each fragment on the file system, on the C3 file system. You see here fragment 1, fragment 2, and so on. And after C3 receives all the message fragments, it will rejoin them and it will reconstruct the MIME envelope soap message that was sent by C2. It will reconstruct it and it will recreate the original large file. After this is done, access point will notify the plugin, in this case the file system plugin, which will copy the file to the shared file system plugin, which is used for the integration with the C1 and C4. And C4 here, it will take the large file and it will consume it in the backend. So this is how the whole process is working more as a granular level. Okay, then I will move to the next slide. So now let's talk about the security when sending large files using split and join. So each message fragment is signed and encrypted like a regular user message. And but the user message is not signed and encrypted because yeah, it's let's say that the non-repudiation of origin and receipt is ensured by all these fragments that are signed and encrypted individually. So because of each fragment is signed individually, the signature of all the fragments commits the sender to the content of the fragment message. And collectively, all these fragments ensure that the entire source message has been signed. Then fragments are individually numbered, and the number of fragments the source message is communicated to the receiver, because the receiver must know how many fragments it must wait before starting to rejoin all the fragments. We will see later on an example of this of how this let's say metadata is communicated between C2 and C3. And because each message fragment is signed, it is not possible to alter the source message content by, let's say, reordering, adding, or omitting fragments, because the signature will fail. And as we said before, receipts are generated for each message fragment and returned synchronously to prevent unnecessary message retry, like in a normal sending of a user message. After all the message fragments were rejoined and the source message was created at C3 side, the C3 will send a receipt to indicate to C2 that it has successfully rejoined the message. So this is how this let's say how the original source message is the status for the original source message is marked as acknowledged because of the last receipt is coming from C3. There were some, let's say, concerns about the non-repudiation of original receipt of split and join, and therefore this process has been reviewed by a security consultant, which, in his opinion, the non-repudiation of signing is obtained by transitivity. So I was like we were explaining before, because of all the message fragments are non-repudiation is ensured by all the message fragments. By transitivity also ensures the non-repudiation for each for the source message. You can see here in this document I put here a link. More details about this, let's say, this analysis. Now let's talk about the reliability when dealing with split and join. So the message retry is applied to each message fragment. So in case one fragment fails, then the access point will try to resend that specific fragment. The source message, there is no retry for the source message because yeah, C1 sends to C2, and then yeah, there is no retry foreseen in this case. Or regarding the duplicate elimination, this is applied for both message fragments and to the source message. So the access points will know how to deal with in case the fragment is resent or the source message is resent. There are many. So now on the next slide, we will talk about error handling. So when sending fragment messages, there are the reports are the errors are reported synchronously, as it is the case in the common profile, and but for the source message, let's say if the source message, if there was a failure rejoining the fragments, the error reporting for the source message is done asynchronously by using by sending a signal with an error. I've listed here the most common errors that can happen when dealing with split and join. But if you want to see the full list of errors, you can see it in the specification. I put here a link if you are interested. So, what are the most common errors that can happen when sending large files using split and join? We have here the 40 error code, which indicates that a fragment was received which relates to a group that was previously rejected. So, as you know, when sending large files with split and join, there are the fragments belong to a group which has an ID. Then the next error code indicates that there was a bad fragment number. And in this case, the incoming fragment has a higher value than the known message fragment. So the known, if C3 expects, let's say, 10 fragments, then in this case, it will receive, let's say, 11 or more than 10. So it indicates that there is a problem. Next error is a 51, so the 51 error code, which indicates that the time, let's say the time configured for sending a message with using split and join has passed. So let's say if in the configuration it's indicated that the file, the whole fragments, so including the source message, must be sent within 10 minutes. If this time is overdue, so let's say the whole process happens in 12 minutes or so on, there is an error that is triggered and the whole process fails. So this must be properly configured. Let's talk about now. Let's talk about the compression when using split and join. So the compression of a source message is done by the sending a message after submission, but before the splitting. And why this is done is because this in general it results in a better compression ratio than if the compression was to be applied separately to fragments after the splitting. Similarly, the decompression is done after the C3 side is done after all the fragments have been joined, but before the message delivery. Let's see now how we configure split and join in Domibus. As we saw before, the first requirement is to configure Domibus to save the message payloads on the file system. So for this, we have two properties that you see here on the screen. So the first one is for the file, the actual files, the fragments, and the source message. The second one is used for as a temporary directory because there is in the process of sending and rejoining the source message, there are some say operations that require some temporary file system. Apart from this, split and join must be activated in the Domibus pmod file. So this has to be done on a specific leg configuration. I have here a specific leg. Switch my pointer again. Okay, so I have here the leg configuration. This is what you see here is a normal configuration of a specific leg. What is different here is this attribute here, which is called splitting and refers to a configuration for a split and join. In this case, this configuration is called default, but you can add any, let's say you can set up any name for in this case. So this default configuration, you can see it here, which says the following. So I want my fragments, my source message to be split into fragments with a size of 500 megabytes. I want to activate the compression for the source message before the creating the fragments. And this is the time that is allocated for all the files to be sent or received. So if this the whole transfer takes more than this time, the process stops and the transfer is considered as failed. So this must be properly configured. Let's say if you send 100 gigabytes, of course you have to adapt this this interval here. Here we see an example of the SOAP envelope that is created when sending message fragments. So what is different here is until this part, you know that you see here the header. Until this is a new section. You don't have this when sending normal user messages. You only see it when you send message fragments. So let's see exactly what these let's say elements are. So what is the meaning of these elements? We have the group ID here. So for all the message fragments that are sent and associated to the source message, we have this group ID to identify that the fragments belong to the same group, so to the same, let's say, source message. Then you have the message size, which indicates the size of the fragment. And here you have the indication of the so how many fragments are in total, what we were discussing before. So in this case, the C3 must expect in total 12 fragments, and this is this fragment that we are seeing here is the 9th fragment. This is what is saying here. And the message header, it's more technical and refers to the source message and the main parts that are generated in the source message. So this is an indication for C3 how to rejoin the source message. We can see also here that the compression has been activated, so application JZip, and you can see here the compressed message size after the compression has been applied. Now we can see the reception awareness. So the receipt that the source that C3 sends to C2 after it has successfully rejoined all the message fragments. So this is an indication sent by asynchronously sent by C3 to C2 to let C2 know that the whole rejoining process has happened correctly at the C3 side. So in this case, after C2 receives this receipt, it will change the status of the source message into acknowledged. Now,
since I promised I would interrupt you to make it a little bit more dynamic, there is a question whether MF message size refers to the size of the source message or of the fragment.
Here you mean this part? This is refers to the fragment size.
Okay.
Okay. Are there any more questions?
No, not at the not at the moment. There were a couple which I already replied, but if you want to clarify once again about the well, there is a question about what happens if the payload is already encrypted. In principle, I don't think there is much to add. The Domibus will process this in a payload agnostic way. So whatever is sent from the C1 side will be received identically on the C4 side.
Exactly. Domibus is agnostic, is payload agnostic, and it does not look into the payloads that are, let's say, to the contents of the payload sent by C2, well, by C1.
And there is a new question now. What happens if C2 sends a file larger than C3 may accept, for instance, due to some limited, let's say, limitations on the C3 side?
Well, in this case, I suppose that the process will fail at C3 side, and if C3 is able to send the receipt containing what we are seeing here on the screen, if it's capable of sending, because I understand it encounter an error, so it will send a signal containing an error informing C2 that the rejoining process has failed, or if the process completely fails at the C3 side, remember that we have to here the join interval, and after this interval, is exceeded, the C2, for instance, the C2 side, the transfer is marked as failed. So there are two mechanisms for transmitting and for say dealing with errors when talking about split and join.
Okay, thank you. No more questions at the moment.
Okay, then I will go to show you a demo how to send a message using split and join and the file system plugin on Tomcat. But before showing you the demo, I would like to show you a quick overview of how the process, how C1 sends a message to let's say to C4 via file system plugin, because this is what we will see here. So how the process is working. So we have here the backend application. We have C1, which will send a message to C4. How this is happening, it will copy the file in the out directory. So you see here that we are using the file system plugin, and the file system plugin works with a structure which can be seen here. So you have the out directory, in directory, sent and failed. The out directory is for messages that must be sent to C3. In directory, we can find here messages that were received from other access points. In the sent, we will see the files that were sent successfully, and failed, of course, the files that were that failed to be sent. So in this case, C1 copies the file to the out directory. The file system plugin will poll this directory regularly, and it will see that it has a file to be sent. It will take the file, it will compose the message that is sent to Domibus. Sorry, I think here is, I wanted to show you that after the message is sent or failed, it goes from out to one of these directories. Okay, so file system plugin composed the message, sends the message via the internet to the C3 access point, and then it is received. Okay, so this is how the transfer of file is happening at C2 side. Now let's see how it's happening at the C3 side. So in this case, we are here. We are C3, and the C2 sends us a message. So it sends let's say a response or any other message, travels via the access points. It arrives here in the Domibus side, which will inform the file system plugin that it has received a message. File system plugin will copy the received file into the in directory this time, and the backend application will read the file from the in directory. So C4 here will have to poll regularly to check if it has received messages in the in directory. Similarly for like it was the case for the out directory. So this is how the process is working using the file system plugin. Now let's see how this is happening. So I will share my screen. So this one. So I have here on the left side, I have a C2. And then on the right side, I have a C3, which will receive the messages. These are two instances in the cloud, in the Azure cloud. These are Docker instances. Maybe to show you here that, so this is the blue instance, the other one is the red instance. I will show you again that I have activated upfront split and join. See here the splitting configuration. Similarly, on the C3 side, I have here the splitting activated. So this is already done. And I can show you also that I have configured Domibus to store the payloads on the file system. See here, I have my directory configured. Similarly for C3 side. Okay, so what we will do now, we will copy. So I will go to the console. Here I am already in the, I'm connected in the Azure instance where I have the, my two instances running, and I will copy. I will copy a file of 3 GB into the out directory of C2. So C2 is here. I'm into the C2 configuration file. You can recognize here the configuration files of Domibus. In this case, I have the FS plugin files directory, which is configured at the C2 side to, and also by the C2 side is configured in the file system plugin. So you can see here that I have my directory. So I have my out directory. In the out directory, I think this is a test that I did before. So I will.
There is a request to zoom in, Cosmin. It's difficult to see.
Sorry. Is it better?
Maybe a bit more. I think it should be fine.
Okay. So I will remove this payload first. Okay. And then I will copy. I will copy a payload here, which I already prepared. Large files, payload 3 GB. So I'll copy a payload in this directory. And then we'll see what how the splitting of fragments will happen. So it takes some time to copy. Okay, so it finished copying. Let me check that there are no permissions issues here. So you see that we have our file here. So it has around 3 GB of file, and soon Domibus will start. Let's say will detect this this file on the out directory, and it will start processing it. It seems that we have an issue here. Let me second to this.
Please zoom in.
Yes, yes. Indeed, sorry. So I will exactly into the container to see what is going on there. So cut.
You moved your camera. Maybe you can
Yes, I have my I have a laptop in front of my let me double check again. Let me resize my screen because otherwise I will not see anything. Okay, just bear with me a little bit. All right, so I will connect again to the instance. Okay, so which one is the sender? I think it's this one. Okay, so I have here my logs. Actually, I need to check them because okay, so it seems that this is the C3 side, and then we need to do the same on the C2 side. Which is this one. Okay, so it was a false alarm, I think. It was a bad credentials. Let's check if Domibus started to send messages in the meantime. So not, it seems not. So we need to activate logging. Okay, so it seems that my message failed, so it should be here. No, something is wrong there. Could it be that I did not copy it previously? So I will do it again. I think I copied in the wrong directory. So copy the large files, payload. Okay, let's see what is happening now. Okay, so it should start. It should start polling and then sending the payload. Let's see this in the console. If it did something, seems not. My login is on debug. Wait, I think I'm on. I need to tell it. So it seems there was an issue here. So there is a permission denied. Okay, I think I know what is happening here. So yes, all right. GH on, oh, yes. Okay. I think now we should be fine. Was it here? Was in this one? Okay, let's see now what is. So it seems that it start to process it this time. It will take some time before processing it because yeah, last time it took like when I tried it, it took like 3-4 minutes. So maybe in the meantime we can take some questions.
Indeed, I can maybe read out. I was trying to reply in the chat, but the last few questions are from Katalin Marku, who is asking first some questions about what eDelivery is. Very briefly, because indeed we presented this in the beginning of the webinar, eDelivery is not a full system. It is a building block which is meant to be integrated in a bigger architecture. It is used in eEvidence digital exchange system. I'm not familiar with the acronym EESP, but in many other ones, tens of other projects. And I think to see a little bit in more detail about eDelivery, either wait for the recording of this webinar, or if you would like, there is a link which was pasted by my colleague a bit earlier. I can repaste it with the recordings of previous webinars, and in general, in all webinars, we explain a little bit what eDelivery is. So this is the link. I just put it back at the bottom of the chat. You can see more there. Then the second question, I will read it for Cosmin. So configuring the size and number of fragments has to be done every time. And is it in the interface or in the config file? I'm not sure about the question. What does it mean every time? It's usually done per leg, but maybe Cosmin, you can explain a bit better.
Yes, I can explain it. So the configuration is happening per leg indeed. We have here an example. So we have this leg configuration, and we see that for this leg configuration, we have activated the split and join. We have here the splitting attribute, which points to the configuration of the splitting, so of this split and join configuration, which indicates in this case that the fragment size is 50 megabytes, compression is true, and the whole process must happen within, I think it's 24 hours here. This is in minutes.
And maybe it's good to also explain briefly what a leg is, what it means, and how frequently do you have to configure it?
Basically, a leg is it's a term specifically for the P mode where you specify the service and the action that and also the MPC and also some, let's say, configurations in here. But the most important here is the service and action, and this leg will be matched against the user message that is sent by C1 to C2, or when the message is no, basically from C1 to C2. So let's say you send a user message which has this. Okay, here is the reference to the service, but if you send a message using this value and this action, it will match that specific leg, and it will take into account this configuration here. Configuration, when I'm saying configuration, I'm talking about the split and join configuration, the reliability, the security, reception awareness, and so on. Compression and so on.
So if that was still not clear, when there is a message exchange, a message is labeled with several bits of metadata, among which these service and action that Cosmin mentioned, and then the configuration, at least of the split and join use or the non-use of split and join, is done for a specific service and action. So if you are exchanging different types of documents, you can label them differently, and all the documents carrying a specific label or set of labels would match a specific configuration. You can clearly find much more details in the admin guide, but very briefly, this is where the configuration is done. Moving on to the next question, is sending done only by copying a file in the out folder, or does it have an interface? I expect the question refers to a user interface. So Domibus and in general many eDelivery access points, they are not meant to be used directly by the users. They are typically used in a combination with another IT system which is user facing. So normally the end user will never work directly with Domibus. This will only be the administrator of Domibus, but not the end users. Therefore, the users should not, or you should not expect that Domibus provides user interface for the end user. Now, how can the third-party IT system, the corner one, the backend, communicate the file to Domibus? There are multiple options. And at the moment, when we are talking about the large files and only about the large files, of course, if you are talking about a smaller file, or actually a file not using split and join, then you have multiple options. But in the context of large file split and join, at the moment officially we only support the file system plugin, and the out folder is a property of this file system plugin. Cosmin will come back to the limitations towards the end of the presentation and explain also what you can expect from the future. But at the moment, it is only through copying the file in the out folder configured for the file system plugin. But this should not be done by the end user. Cosmin here is doing it manually because he acts a little bit like an IT system. But in a normal setup, you would have an actual IT system with a user interface that will handle that in the background. Cosmin, if you want to add anything to this question.
No, I think we have provided all the details, Bogdan, so I think I don't have any.
Then we move to the next question. How do you correlate the saved zip archive in the out directory with the message submission to destination C3 access point? I can read it again if you would like.
Yes, it was not clear actually.
How do you correlate the saved zip archive in the out directory with the message submission to the destination C3 access point? I think you probably need to mention the way the metadata works for the file system plugin.
Yes, indeed, I can show that. So I think here we need to go maybe deeper in how the file system plugin is working. So we have seen before that the file system plugin has this special out directory where you can just copy files that you want to be sent to the other access point. And in this out directory, you have this special, let's say, file called metadata. I will show you the contents of this file. As you can see, it resembles a lot the interface, let's say the request that you use for the WS plugin, the web service plugin. And basically here you have some not placeholder, but the part of the message that will be submitted to C2. So you see here, you say, I want to send the message from Domibus Blue. So this is the party identifier of your access point to this counterparty, so to the access point called Domibus Red. And then I want to use what we were saying before, the service with this specific type, with this value, the action. If you have message properties, let's say like it is the case for the four corner model, and then you list here the CID message of your payload and which MIME type it is. Okay, here I put a wrong MIME type because it was just for demo purposes. But normally here, if you use application JZip, you need to put here application JZip. So in this will be used to match against the P mode of the C2 side, and it will be used to construct let's say the final user message.
And maybe you could explain also the message ID, how it is working.
Well, the message ID is I will go here again. Okay, in the meantime, maybe just to say that my large file, my 3 GB file has been sent, and normally I should find it in the sent directory. So you can see here, it was slightly, let me check here. Okay, as you can see here, the file has been renamed. So initially it was named payload underscore 3 gigabytes .zip. Now it has this suffix after the name of the file, which is this. And this is actually the message ID that is sent to Domibus. So by, let's say, at the C1 side, if you want to know what was the message ID that was created for my payload, you have to parse this name and extract the message ID from the name in this one.
Okay, then moving on to the next question. How does the file system plugin recognize that the file is ready for transfer and not just a partial message in being copied from C1?
Yes, this is a good question. Actually, we had many issues while implementing the file system plugin, and this was one of the issues that we encountered. We have two ways of detecting that the file is, say, is not complete and is currently being transferred. One of them is we are looking at the timestamp, the last modification of the file, and also on the size of the file. So let's suppose you copy a file of 100 gigabytes in this out directory. The file system plugin will not submit it because it will detect that either the last modification date has been changed or the size has been changed comparing to the last time that it has read it. So it keeps track of the files that are in there. Let's put it like this.
Okay, the next question has to do with, are you using the splitting feature of the zip format? And there is a link to zip standard, I think, the zip file format specification, where there is a section on splitting and spanning zip files. And then the other question is, are you using the zip 64 format?
So we are not using zip splitting. We are using the Oasis split and join specification. So basically, the file is we create a MIME sub message sub MIME message, and then we split that sub MIME message into multiple fragments. And this file is created internally in Domibus before it creates the fragments.
Okay, thank you. There is a question from Jamila then. The P mode in our project is generated by a tool called configuration management tool. How do we define the leg in our P mode? Does it need to be manually updated for each member state, let's say for each party, or does it have to be introduced somewhere else? I'm not sure if you can answer this question, Cosmin, but if you can comment.
Well, maybe to say that I mean I don't know exactly the requirements in this project, but what I can say is that this leg configuration, as I said, is the main characteristic of it. Whether it will be used or not depends on let's say four main things: service and action, as you can see here. So if you are sending from C1 a message containing a service and action which matches this, and if you are sending from a specific party to your counterparty. So you see here that the leg configuration is used in a process, and this process says, okay, I will match all the legs for which the initiator is blue or red, and the receiver is either blue or red. So if the initiator and the responder are matching, then it will check if it matches also the service and the action. And if there is a match, then it will use that leg, and for that leg you have other configurations attached, like property set, you have the reception awareness, you have the security which is used, compression and error handling, and so on. Splitting, so split and join. So let's look at the leg like a special configuration of Taxis point.
Maybe to complement your answer, Cosmin, so I think that the P mode file, for those of you not as familiar with it, is different, at least partially different for each party in an eDelivery network. It has to be specific to the party. And certainly large parts of the P mode files can be identical from one party to the next, but there is always specificity to each communicating party. And if there is a tool that generates the P mode files automatically, I think there needs to be a clear analysis done of very precisely how the P mode files work. And depending on how the tool is configured, to make sure that it will produce the appropriate P mode for the use of split and join for whatever processes, let's say this needs to be the case. So I think this is not necessarily an easy question to answer in the webinar format, because it will take probably involving the people who are designing this tool to understand what is the input and the output of the tool, and where exactly the split and join configuration must be realized. So we can probably take that offline and provide some further information once we understand a bit better the tools. Then we move to the next question from Tomas, who says, you told that split and join is transparent for C1 and C4. Splitting the large file, the message initiates several delivery processes between C2 and C3. This implicates the separate set of evidences are generated. How is it presented to the sender? Does C1 see only one set of evidences of the whole delivery process, or all evidences for each of the parts?
For C1, this depends. So by default, it will not C1 via the plugin. So when I say C1 is the integration with the plugin, and the plugin can be notified by default only if the source message has been sent or received successfully or not. But you can configure the P mode. So maybe the P mode, the file system plugin, to receive notifications also for message fragments. So in this case, as you can see here, I have message fragments and I receive, okay, I've been logged out. I have the no repudiation of the, so you see here, I can download the no repudiation information for that fragment and I can see it. But this can be also retrieved via the plugins, via specific APIs of Domibus. Maybe I can check here if I have the configuration, plugins, config. Yes, so you see here that by default, the file system plugin does not receive the message fragment notification, but it can receive it. So you see here that it lists all the possible notifications that it can receive. And at the last, you see in this list, you have notifications related to message fragments. So if you activate here on this list, so you uncomment this property file, this property, you activate the message fragment notifications, then the plugin will be notified. And then, of course, if you have a specific custom plugin, for instance, you can take several actions depending on these notifications. And one of them is to download the no repudiation information.
So is it correct, if I'm trying to sum up, that there is one separate evidence, let's call it evidence non-repudiation or acknowledgement for each fragment, and there is also an acknowledgement for the overall message?
Yes, I can go back to the
and depending on the configuration, you could by default only see the one for the entire message, but options exist to also see the fragment related ones.
Yeah, so this is the no repudiation information for the message fragment. I don't have here the part, but I will download it. So here at the end, you have the no repudiation information. Maybe I can go back to the console and I can show you. So you see here I've downloaded the no repudiation information for one fragment, and I can see it here. At the end, you have the security part, like you have it for any user message. And this
please zoom in a bit if possible, Cosmin.
So you have here the security part where we have the hashes of the signature of each payload, and you also have the counter message, which is the no repudiation information from C2 side, which let's say which responds with the hashes that it has received of the payloads that it has received from C2, and confirms that I mean, let's say signs with its own private key and confirms that let's say binds the C3 access point and acknowledges that it has received that message fragment. Once you have the no repudiation information for all the message fragments, it binds the sender and the receiver and proves that they have successfully sent the whole entire source message via transitivity of the no repudiation information for the message fragment. I'm not sure if it's clear for you.
I hope so. we can wait in the chat for the confirmation, but I propose, since also the time is up and we still wanted to go through further slides, that we go to the next question. For those of you who are still interested to stay on for a bit longer, did you find you need to protect against file system corruption for the Domibus file system where the fragments are stored? For instance, do you compute digests for each fragment to ensure the data has not changed before forwarding fragments from C2 to C3?
No, we don't compute any digests in there. So we are assuming that the whole process is working fine. There are no bugs in the access point or in the process.
The question is about file system corruption. So if between the creation of the fragment and the sending of the fragment, if there is something going wrong on the file system.
So when creating the fragments?
Either when creating them or between creating them and reading them to send them.
No, there is no such mechanism for the moment.
Okay, but this is something interesting to consider indeed. Thank you for raising this point, Mihai.
Well, indeed, I mean, if we want to really make sure that this is working fine, then probably C1 must send also the hash so that C2 ensures that there is no problem. So you can do a cross check between the hash sent by C1 and the hash is computed by C2.
So indeed, the integrity of the entire process may still suffer some improvements in our implementation. At the moment, the file system is assumed to work correctly, but indeed, there is no current protection against file system corruption. I think we are at the end of the questions, so maybe back to you, Cosmin, to continue.
Yes, I wanted to show you that in the meantime, the whole process went fine and all the fragments were sent successfully. The original source message has been marked as acknowledged, as you see here. And so this is on the C2 side, and the C3 side. Similarly, it has received the entire source messages, and it has recreated the original source message. I can also show you on the file system that this is the case, and then I can move on to the next questions or slides. So I will go to the red. So this is red is the receiver side. I will go to the configuration, to the file system, to the directory where the file system plugin is using. I'll go to the in directory, which you probably know now that is used to store the incoming messages. And it's not here. The in directory, and wait, why is not here? Because I see it in here. Domibus to Domibus red. Something is wrong here. Yeah, I don't know what happened here. I need to check the log file. So I don't know if you have the time for this. Otherwise,
I propose we move on, Cosmin, since I think it's more important than troubleshooting
yes.
on the spot to make sure we provide higher level information for the webinar, and then we can always come back in writing to clarify what may have gone wrong.
Yes, indeed. Okay. Then a couple of words about clustering. So what happens if Domibus is running in a cluster setup? On the sending side, so one C2 node is splitting the source message into fragments. So not all the one that receives the request from C1. And once this is done, all the C2 nodes can send message fragments to C3. So the whole cluster nodes can take part in the sending of the fragments. On the receiving side, all C3 nodes can receive message fragments, but only one node is rejoining the fragments into the source message. So this is one thing to know. Maybe to...
Cosmin, I interrupt you briefly, even though I think you already covered it, because we got exactly a question about this. The question is, I'm not sure if there can be multiple access point nodes, for instance, in a high availability scenario. If such a scenario is possible, how do the different nodes determine which node must handle a specific set of fragments? I think we explained that it's irrelevant. Any node can do that, but if you want to add anything, this is a question we got.
Yes, indeed. So all the nodes can receive message fragments, and because all these nodes are configured to read and write to a specific shared file system, it means that any node at the end, after the whole process, after all the message fragments are received, any node can rejoin all these fragments and reconstruct the original source message. Okay, then I will move on to the next slide to let you know about the limitations in Domibus about split and join. So officially, Domibus supports split and join only in single node setups and when using the file system plugin and on Tomcat. Unofficially, Wi-Fi and WebLogic are also supported, and including the WS plugin, the GMS plugin. And in clustering modes or multi-node setups, theoretically is also supported. We have put there a warning in red that the use of these configurations, the unofficial configurations, is not recommended in production until we made it official and complete all what is needed.